Hey guys, so this video, I just want to make it a brief overview of all the trigonometry that you really should know to be successful in this course. And if you don't understand a lot of it, that's okay. If you see the description of this video, or I may link them in this video, you'll find some links to some good sources. I've got some videos up there that you can learn all the real trigonometry like this that you that you're going to need to know. So definitely look at the description if you aren't positive that you feel completely comfortable with all of this stuff. So the first thing is, if I have a right triangle, got an angle theta here, this is a right angle, right? This is the adjacent, right? This leg of the triangle is adjacent to theta. This is opposite, and this is the hypotenuse, okay? And we can define certain trigonometric functions. So we've got the sine of theta. Sine theta is equal to, right, that's opposite over hypotenuse. And you probably know the phrase SOHCAHTOA, sine is opposite over hypotenuse. C-A-H, cosine of theta is adjacent over hypotenuse. And then the tangent of theta is opposite over adjacent, which is equal to sine of theta over cosine of theta. Right? And so these are the main identities. Then there's functions, sorry. And then there's going to be a few others that you should know. You should understand the secant of theta is 1 over cosine theta. So you should see that that's, hypotenuse over adjacent. Cosecant theta is 1 over sine theta. And cotangent theta is 1 over tangent theta. And it may be useful just to make sure you understand that this is cosine of theta over sine of theta. Right? I know this is a little bit messy, but hopefully you should really see this. Hopefully this is review. Quick note. Sine, cosine, right? Sine and cosine are always going to be less than or equal to 1. Or this is at least the absolute value of sine or cosine, right? And that's because if it were greater than or equal to, or if it were greater than 1, that would mean that either the opposite or adjacent legs are greater than the hypotenuse, which is completely impossible. And hopefully you should see that. They could be equal, so if theta is equal to 0, right, adjacent and hypotenuse are the same, so cosine of theta would be 1. And you can see these could be negative too. If you're saying this is positive, but if we flipped it, if theta became negative, right, this opposite leg would be pointing down. And you'll see that more as we get into this is not the best way to define it. The best way to define it is really the unit circle definitions, but I just want to give this one first. The other thing is, we know that secant of theta, the absolute value of secant theta, cosecant of theta, this is not like a point, this is just either, is always greater than or equal to 1. That's pretty obvious just from this first one, right? So these are important to know. There's also one other convention that you should know before I get into the unit circle, and hopefully we've got this down. I'm going to erase this. I'll put this in red. So, for example, sine of theta squared is equal to sine squared of theta. Similarly, I don't know, tangent of theta to the 5th power is tangent to the 5th theta. This works for any trig function, and it's just there's a convention that you can put this power between the function and the angle. Also note, the angle is necessary. The angle, right, you're looking at the sine of theta. You could have parentheses here, or absolute value, but that meant to be a parentheses. Now, parentheses there, it's sine of theta, tangent of theta. A lot of the times you'll leave out the parentheses unless if I've got like tangent of 2 theta. Then you'll want to have parentheses so you know that it's not tangent of 2 times theta, right? But, and so that's just, this would be 2 theta here. Okay, just this should all be familiar to you. If not, then you really need to look at the rest of this, because it is going to get a little bit more complicated. So now I've got a circle. I've got a circle of radius r, and it's centered at the origin. I know this circle is not centered at the origin, but it's supposed to. So we've got the circle. It's got a radius of r, right? And I've got some point here on the unit circle, got an angle theta here. So this has a point x comma y, right? And you can see, and see if maybe you can prove this using the SOHCAHTOA stuff, or you could consider this more fundamental and prove SOHCAHTOA from this. But we'll say that sine of theta is going to be y over r, right? Cosine theta is going to be equal to x over r. And tangent theta is going to be y over x, which is actually going to be the slope of this line, right? And so you could also see that from this, the y component is r sine theta, and this will be important a bit later, but an x is equal to r cosine theta. This should be familiar with you. You should know how to apply it, especially in like vectors. We'll have a video on vectors, but it's not going to be too in-depth. It's going to be an overview like this. So you should understand the this, and if r is equal to 1, right, then sine of theta is y, cosine of theta is x, tangent of theta is still y over x, right? And that is called the unit circle if it has a radius of 1. Now, you should also know certain angles, right? The value of trig functions for certain angles. So hopefully you have this down. I'm going to erase it. And so you should know, first of all, how to go from degrees, right, which is probably how you're familiar with measuring angles. You're probably familiar with using degrees. You should be able to go from degrees and back and forth to radians, which is how we will be measuring angles in quantum mechanics and really all of real physics. Right, so to demonstrate radians, right, I'm going to have a circle of radius 1. I'm going to have the unit circle here. I'll do it in a different color. Right, I've got a unit circle. Or even, it doesn't even have to be a unit circle. It can have a radius r again. Right, so it's got a center here. And it's got a radius r. Right, and I've got theta here. Right? And then I've got this length. This length over here is going to be, we'll call this s. And s is the arc length, and this is equal to r times theta. And the way this would work, right, is if theta is measured in radians. So theta is the arc length over the radius, right? And so we know that if the arc length, right, for a full circle, so let's look, 360 degrees, right? For a full circle, we know that s is 2 pi r over r, right? Because that's, that's the arc length of the whole circle if we were looking at 360 degrees. 2 pi r over r, well, this is just 2 pi. Similarly, if we look at half a circle, the circumference of half a circle, right, is going to be pi times r. It's 2 pi over 2. So 180 degrees is going to be, we've got pi r over r, so this will be pi. And now actually for a unit circle, if this thing is 1, s will equal, right, the arc length and the angle measure will be equivalent. And so that's going to be useful for the unit circle. So hopefully you should see why this is a useful definition. These are radians. I'm sorry. So these are degrees. This is radians. It's the projection of theta, right? It's the projection of theta, essentially, and then divided by r, right? Or for a unit circle, the measure in radians is exactly the projection of theta onto the circle. With pi radians, we can see that 90 degrees will be 90 degrees, you can use the same logic. This is pi over 2 radians. 270 degrees, right? 270 degrees will be 3 pi over 2 radians. You can go ahead and show that these are true based on our definitions. Okay, so now you understand radians, and then you can look, see if you can figure out, just based on this pattern, what 45, right? I'll give you a hint, it's pi over 4. 45 is pi over 4. If you look at 30 degrees, which is another important angle, 30 degrees is going to be pi over 6. 60 degrees will be pi over 3, right? And so be comfortable with radians, know how they work, because that is the angle measure that we're really going to be using in quantum mechanics. The last thing is just understanding sort of how the values of sine and cosine work. And I'll leave that to most of the other videos that I've got. You should know the sines and cosine values. So no sine, cosine, tangent, cosecant, secant, and cotangent for all multiples of pi over 3, or sorry, not pi over 3, pi over 6, and pi over 4. All multiples of pi over 6 and pi over 4, so that, some of these will overlap, like pi over 2, or just pi, those are all multiples. But all multiples of pi over 6 and pi over 4, you should know the sine and cosine values. You should also understand the graphs of sine and cosine. And just to show you here, sine is periodic, and cosine is also periodic, right? This is sine of theta, or sine of x, if this is, this is theta and this is sine of theta, right? It's got a peak here at 1. And I'm not going to be showing all of this graphing. Hopefully you will watch these videos if you don't already know this and see. Cosine is just a shifted version of sine, and all it does is it starts up top here, right? That's cosine. Now, the one last thing, and this is really important to see, sine is an odd function. Sine is odd, meaning sine of negative theta, right, is equal to negative sine of theta. Cosine of negative theta is even, or cosine of theta is even, since cosine of negative theta is equal to cosine of theta. And this is, right, odd functions, f of negative x equals negative f of x, even is f of negative x equals f of x, right? And you can see if we, flip this across the y-axis, it's negative itself. If we flip cosine across the y-axis, it's the same thing. So this should all make sense. Again, this is a really brief overview. If some of this is not super familiar with you, right, you should know trig values. No trig values for multiple, right? So if all of this is not familiar with you, watch the videos that I've got in the description. Okay, that's it for the small brief trigonometry review.